So good morning, everyone. Shubha Prabhat, Shubhodaya, Kalai Vanakkam, Shubhodaya Andaga, Shubho Prabhatam. To all the attendees here on Google Meet and all the audience from Facebook Live and YouTube and the members of the club. We have people from every possible corner of India. So we are so glad to welcome you all on this auspicious day of our club. It's our pleasure to see the large audience at the inauguration ceremony. Your presence makes us very happy. Fine.
Would like to thank our member Srishti Patil for scripting the trailer and Aman Sinha for directing it. Athaang has been an adventurous journey for us to bring together like-minded people on this single platform. Thus, I request Swastik to begin the event with the introduction of Athaang. Swastik, over to you.
Thanks, Sandra. Athaang is a platform for learning, understanding, and sharing ideas to the broad spectrum of astronomy with students from rural areas of India. Now, begin for what we have been waiting for since long, the inauguration. I request our speaker, Anand sir, to inaugurate the club.
Sir,
Hi everybody.
hello sir. Sir, we will be starting a
Yeah.
video which will show you the inauguration ceremony.
Okay.
Yes.
Yeah.
And now I officially declare that our club has been officially established and as well as inaugurated. So thank you, sir, for attending our inauguration ceremony. And every idea or field has a history behind it. Similarly, astronomy too has emerged and evolved for centuries. Why is it so important to learn about astronomy? One thing is we learn from mistakes, and every seeker of fundamentals carries the luggage of history in order to make it better and closer to the truth. So, at some point of time during your own voyage of discovering these subtleties, going back to the roots always helps in a better way. Hence, it is necessary to learn the history of astronomy before diving into the vast universe. To do so, we are so glad to have Mr. Anand Gaisa sir, who would take us through the journey on the history of astronomy. Drishti, will you please go ahead?
Yeah, am I audible?
Yes, you are. Yes.
Yes. You're audible.
Now, before we head to the talk by today's guest speaker, let's first find out more about him. Anand sir is former member of Homi Bhabha Center of Science Education. He joined in 1979, starting off by developing age-appropriate illustration for kids at the center. Soon after that, he also started contributing to different activities at HBCSE, such as popularizing astronomy among students and teachers, activities on mathematics, photography, and much more. Today, he is one of the leading scientific writers in Maharashtra, authoring various columns such as Kutuhal and Gammat Ganit in Sakal, a Marathi daily. He has also written several books on astronomy and science, which are very informative and fun to read. They're one of the reasons for young mind to get interested in beautiful aspects of astronomy. Being an enthusiastic speaker, he loved to enlighten children by talking about astronomy with them. He has also written scripts for television performances on Balchitravani and for All India Radio for popularizing science. His friendship with Professor Mohan Apte, who himself was a great writer of astronomy, was a motivation for him getting into the field of scientific writing. The books of these two writers are well recognized in society and have an important role in popularizing astronomy and in general science. He has inspired a lot of students to pursue astronomy as a hobby or a career. We at Athaang are honored to have him as a guest speaker here at our inauguration ceremony. Yeah, Prachi, over to you.
Yes, even you will get a chance to interact with Sir and the core team later. If you have any questions for any of us, you may put them in the chat box. For Facebook and YouTube attendees, you may put your questions in the respective live chat, and all the questions will be answered in the Q&A session after the talk. Now, we request our speaker to start with today's session.
Okay, thank you very much. Uh, I would like to share my PowerPoint presentation to all of you so you can see it. It doesn't contain any audio video sections, only some pictures and all that, and I will be just narrating them. If you have any questions, you can just put in chat so I can see them and then I can tackle them. No problem. So can I start my presentation?
Sure, sir.
Yeah. So I will now present
Yes, sir.
the history of science, basically history of astronomy. So history of astronomy for Athaang, I have prepared this slideshow, and let us go to the archaeology of astronomy. Something like what happened beyond our estimated value of science. You know, when you call science, we take it that just 400 years back, someone called Galileo started something using a telescope and seeing the things, and then the astronomy and everything advanced. But before that, many things have happened. So let us learn them first and then go ahead. So the 1 second. So we have found a place called Stonehenge. Now this Stonehenge is from England, basically, Salisbury, Wiltshire, but there are about 200 such places. They are called Stonehenges, a circle of stones with some part of it is like some doors or windows, and there is a big pyre in the center from which, if you see, then you will see the rising sun at solstice, at equinox, a winter solstice, or summer. uh, at least one thing is essential there, that the rising sun at various stages, the rising of moon at various stages, they follow the rule that they will just come in and go out from the doors only. So it is like that, and this is a very before Christian era, 4,200 years back. Okay, so we found something. People think that this is a religious place or something, but religion is always joined with science at that time. Okay. It well. Then you see actual photograph of a Stonehenge at sunset on winter solstice. So the sun is setting now. Okay, but it is going through that gap of those doors. They call it doors, but it is just the gap. But one thing is sure, that these stones, each stone has a tonnage of 30 to 32, and they have been brought there on Salisbury from 200 miles away. And what a journey it would be to just build a circle of stones. So this is, we call it the first observatory ever known. Then we go to a Venus tablet. Okay, it's called Amisa Dukwa. There are 63 tablets found from the Enuma, Enu and Enil catalog. That is a catalog. It is called 3-star catalog. Means there are 3 positions of stars, or 3 parts of the sky has been made in the mid 7th century BC. It is a cuneiform type of tablet, and it has recorded the rise times of Venus and its first and last visibility on the horizon before or after sunrise and sunset, the helical rising and settings of the Venus. In the form of lunar dates, it has been written. So these observations are recorded for the period of 21 years. Record was kept of Venus setting and Venus rising. Means the Venus we see Venus at after sunset or before sunrise. So when it is seen in the morning, the time when it stops from morning and starts beginning to see seen from western horizon, that was all written here. Okay, and it is mid 17th century BC. So we are going from BC to now AD. So built in 634 AD, this is the oldest observatory in Korea. This is a Korean thing. Okay, so in Korea, there is a very type of thing. Okay, a tower. So a man can climb here from the stairs, go into it, and then he looks from this window. This is a square window. From this he looks the sky. So only some part of the sky is visible. Then why this is made? This is to avoid the sparse light which is coming from here and there. So avoiding light for this observatory is seen. But who has used it and what has outcome of it, we don't know yet. It is not available. But these such type of 3 observatories are there in Korea. But this is a well maintained just now. Okay. Then we come to the region of Babylonia. Now in Babylonia, all the Rashis, what we call Rashis or zodiacal signs, they have emerged. Okay, they have seen many things and they have given names to them. And in Babylonia, there is a Hammurabi. That is the name of the king. That is the time of the Hammurabi. But here you can see this is also BC, 1792 BC to 1750 BC. So this area, this is a area of all rivers. Okay, this is where we call the actually all the cultivation started. Cultivation of many things have been started here, and then all the cultural aspect is also seen from here. So there is this king, and he is taking oath, and he is taking oath before. This is moon, this is Venus, and this is the sun symbol. So he is taking oath for a kingdom, to becoming a king, and before these three. So there is always a cultural and religious aspect seen related to astronomy. For many years it is like that. Okay, so there is a German in Germany just 10 years back, this seal is found. This is a coin type of thing. Okay, this is second millennium BC. That is also old, but this is bronze. So we call it a Bronze Age thing, and a record of moon, sun, and you see 1, 2, 3, 4, 5, 6, and 7. The 7 sisters, mean pleats are here. We exactly don't recognize which stars are here and which stars are not there, but here they say it is pleats. Okay, so Pleiades, and what is this? We don't know why this is there. One part of it must be here, which is fallen down. Okay, so this is a depiction of a celestial bodies on a coin. But a concept of heavens was there, just like that. Earth is something like this. Okay, sun, all the stars, moon, everything is like that, and there is a border to it. And if you want to look for the heavens, you have to go beyond, and then there is a space. But we don't know actually what it is, what this is, what this means. But there is a concept that something like ether is there, or because everything should be, but there is no concept of a totally vacuum space. So everything is filled with something, so they call it ether. Okay, either ether is containing. So all the planets and stars and everything is in ether, what we call is universe. But again, the universe was only whatever is observable sky at that time. So the total vastness of the universe is only which is seen from a place, the sky, which is like a dome shape, and under that dome everything happens. Okay, but then came Greeks. So Eratosthenes, which is 276 to 195 BC, so he told everybody that Earth is a sphere. And how he calculated, so there is a shadow, or you can see the sun there, and you can see directly exactly at 90 degrees, you can see the image of the sun in the water well there. Okay, but there is another city not very far away, it is just 200 miles. But 200 miles is too much at that time. So when you go from here to here, you see that if this pillar is there, then there is a shadow. So if on the same day here you see no shadow, so here it is a no shadow day, and here it is a shadow day. So according to him, because of the curvature of the earth, this happens. So he calculated that here he measured the angle as a 7 degrees actually. So if this is 7 degrees, then there must be some radius, and there must be something like this. So he has accordingly calculated the radius of earth, and accordingly the periphery of earth. So the total volume of earth, he first calculated that earth is round. It is 276 BC. around that time. So something has been done exactly with mathematics using some intelligence, I can say. Up to that, only heavens and all is imaginary. But here we start. Then there was Ptolemy and his cosmos. It is about 100 to 170 AD. So Ptolemy's cosmos was the celestial regime is spherical and moves as a sphere. So he told everybody that the celestial sphere around us is moving, because everybody was considering the earth, though it is a ball-like thing, it is stable and it is at the center of the universe. Okay, the earth is at the center of the universe and everybody moves around it. So how they move, so all you can see the zodiacal signs are here. Can you see? So but they are moving like this, and but he said that it is not a flat thing. They are not moving along only one line or one plane, but it is a total sphere, and that sphere is moving. So that's why this has been actually continued here, no problem. But there is another method to show that this is sphere. So it is called a sphera zodiaci. So this is a sphere of zodiac. So zodiac has also a sphere, not a circular or not a plane. Okay, so this thinking was there. Then you see the earth is at the center of the cosmos. I have already, you can just go on reading it, no problem. Next comes the Arabian scholars. In Arabia, there are many observatories. Also, we know somebody called a poet. He has a very good observatory made in Baghdad. It is still there. Okay, it is called. I don't remember the name, but here Abdul, we call it Abd al Rahman al Sufi. He written a book of fixed stars. That is a compilation of Greek and Arabian constellations, and naming of the stars was done by him. And all the can you recognize 1, 2, 3, 4, 5, 6, and 7? These are, we call it Saptarshis or a great deer. Can you see a great deer here? Here are the legs, this is the tail, and this is the great deer shown. So he has actually made a map of the sky on a circular globe, which is a copper globe. And you can also see that there is a person here. Okay, can you see something here? So all these creations, and he has given names to all these stars. And today also his names are still in the use, which are all started by Al. That Al Sufi has made Al. So Al Nitak, Al Nilam, Al Debaran, all these names are from his catalog, a book of fixed stars, which has made at about 903 to 986 AD. He has also developed this one. This has to show the positions of the sky whenever you want it, all 12 months of a year. Okay, so if you just, this is a pin, you move the pin along, then there is a circle of sun and there is a circle of moon around it. And there are zodiacal signs also created here to show them. Okay, so this is actually a planisphere. Okay, a planisphere. You can calculate it. Okay, so this was also done at that time, but this is not credited to Abdul Rahman al Sufi, but somebody else. Then at that same time, very far away in the American continent, but this was known to us just in the 17th century. It is called Mayan culture, Mayan civilization. So in Mayan civilization, in this period, 800 to 900, and this is an observatory. Okay, and Mayan astronomers, they are very much depending about around again on Venus. So all the observation, naked eye observations, because definitely no telescopes was there. So again, Western and Eastern coming and going of the things. So they have calculated that one cycle. Okay, that one cycle is of 584 days. So 584 days of that period was calculated here. Here also you can see that there is door. Up there also there were 8 doors, and there are many things you can calculate from the structures there. So if you go and see the Mayan culture, so this is a called Calacol, and this is as Aztec, near Aztec actually. So this is also a development for observational sky. Okay, but then there is a vast difference of India and all these things. In Indian culture, we just go back to 500 BC and we see that there are many things happening here which is not known to European cultures. Okay, this was not known at all. They were not connected directly. They were connected somehow with something like this from here, and from here there was some ships were going there, and a we can call it that resham. Okay, silk and masala, both of them spices. So they were exchanged, definitely. I don't know how they were exchanging, or they were in barter system or what not. But we can see that there is a Magadha, Kausambi, Bhojaraja, and something like Kalinga here, Indraprastha. So all these things are totally connected to each other, and then there also some observation of the skies were made, and they have also a written thing, though there were systems of just remembering everything in the slokas or something like that. But we think that what we see in astronomical observations in India began very early in ancient culture due to their using timekeeping. See, the difference is just to see the sky and just below uh, actually see them as gods or something like that, and do some rituals was not there. They were looking at the sky for timekeeping. Okay. Next is, because why the keeping was more important, because it has to assist the agriculture. Then astronomical observations simulated growth for mathematics, especially geometry. Okay. Then it was used in navigation. I will come to it afterwards, and how this is a summary. It is also very sensitive cross-cultural interactions and can give a detailed map of interactions between civilizations. I am referring this to a person called Varaha Mir will see what it is. Then tracing the evolution of astronomical ideas and technologies is therefore the study of intellectual growth of a culture which is developed in India. So there are actually 4 different parts, I can say. That one is Indus Valley civilization, which was peaked at that time, but I don't think anybody found some astronomical things there related to astronomy. Any development was there? Nothing was like that found. Okay, this was around 2500 BC to 2000 BC. So nothing was there. There is no evidence available today to suggest that Indo-Aryans were advanced. We call it Indo-Aryans, okay, according to what British people told us. But then ancient Indian astronomy, we call it ancient. After that, it has again 4 parts. One is Vedic period, so before 1500 BC. Then it is called Vedanga period. Veda are 4 Vedas, and Vedanga means a different kind of thing, which is different writings from Vedanga. So it is called Vedas Anga. Okay, 1500 BC to 500 BC. Then it is called Jyoti Siddhanta period. So Siddhanta means well-known, established things, which is called Siddhanta. That period, okay, it is about 300 AD to 1500 AD. And then we call it a modern time. Then after 1500 AD, we call it modern time, just now. Okay, I'm not talking much about this because we are talking about history. So I am just, I will talk just a little bit about this afterwards. But we'll see from here to here what happens in India and also abroad, both things. So, Vedic astronomy. Oldest astronomical references are found in Rig Veda and Yajurveda. So there are 27 nakshatras. Somewhere a 28th Abhijit nakshatra is also mentioned. See, the nakshatras are only along the path of the sun over the year. Okay, but it was not mentioned over the year for the sun, but only for the moon. It was calculated as the moon's daily path, which change. Moon changes from one nakshatra to second nakshatra every day because he is moving around Earth in 27 days. That was calculated. So it was the measure of month and days. It is nothing to do with year. Then in early Rigveda, Mriga Shirsha, that nakshatra is called as the Agrahayana, means the first. Why? Because at that time, just now what we see, Chaitra or the first equinox, which is called a summer equinox, starts in the nakshatra of Uttara Bhadrapada. Okay, so at that Rigveda time, it was Mrigashirsha. So exactly that Vasanta Sampata point, which is called equinox point, has moved over the ecliptic. Okay, so we can calculate time again. In Yajurveda period, it was known true sidereal year is longer than 365 days and shorter than 366 days. Then during this period, a year comprising of 12 solar months and 6 rutus was recognized. The Vedic astronomers evolved a system of, they were calling a yuga. Every time it is a calculation done of 5 yugas, 3 yugas, 4 yugas, but every time the years in one yuga are different. Okay, so at that time, means at Vedic period, it was a 5-year yuga. After that, it changed. Then in Vedanga Jyotisha, (1400 BC), there is a clear reference that winter solstice point was close to a Dhanistha. Dhanistha nakshatra means Delphinus. So this situation was around 1400 BC. It is also mentioned that summer solstice was in the middle of Ashlesha. See, the first reference was Mrugashirsha and now it is Ashlesha. The Vedanga Jyotish also deals with ecliptic calendar and motion of sun through year. So there is angular distance measures were there at that time, which is clearly mentioned that one kala is 60 vikala, one ansha is 60 kala, one zodiacal sign is 30 degrees, and one circumference is 12. Means a total 360 degrees, which 12 zodiacs. Okay, so time is also one ghatika. One ghatika is 60 pel. Pada, it is called pada. Padas, 60 pada, one ghatika. One day is 60 ghatika. 1 month is 30 days and 1 year is 12 months. Okay, so these 12 months and 1 year, this is 12 zodiacs, they are, yeah, similar. These are similar, but these are not similar actually, because this is Ansha and one day is totally different thing. So time and angular distances are totally different. The author of Vedanga Jyotisha calls himself as Lagadha. So if you go to Lagadha, how detailed he has described. See, in Vedanga Jyotish, a yuga consists of 5 solar years, means 67 lunar sidereal cycles, 1 at 30 days, 1 at 35 sidereal days, 62 synodic months, 1 at 60 tithis, 135 solar nakshatras, 1809 lunar nakshatras, 1768 rising of moons. It also mentions 10 ayanas. Ayanas means actually sun's movement through one rutu to another rutu, and 30 rutus in a yuga. So when it is a yuga, then all these things is mentioned. So detailed observation and mathematics was there with the observation of the skies, with the observation of the movement of the moon over the skies. In Atharva Veda, the terms of Kali, Dwapara, Treta and Kruta Yuga. So the number of yuga becomes 4, not 5. And then too many years were comprised in one yuga. So in one Kruta Yuga, 17,28,000 years were mentioned. This is 1296 years. This is 864,000 years, 432,000 years. So Kruta Yuga, Treta Yuga, so this is bigger and it becomes shorter. But 4 yugas means Mahayuga, and that takes 43,20,000 years to complete. Then it is, they call it that 71 Mahayugas will be there. It is called 1 Manvantara, so 14 Manvantara plus 1 Kruta Yuga is a Kalpa, and 2 Kalpas is 1 day of Brahma. So that calculation was done at that time. So a astronomical figures is always there in the culture of India. That was not there in Greek culture. I don't know why. Because I think in Indian cultures, decimal point is more important, which was here, but all other aspects of mathematical calculations, there at Greek period or Roman Greek period, they are based on 6, 90, 36 and all that. So, and they are not using decimal things. Okay. So then came Mahabharata. There was a lunar eclipse followed by a total solar eclipse in just 13 days in war zone. The war zone of Mahabharata is called Kurukshetra. If you call Kurukshetra as a point on the earth, then if you take these 13 days, okay, difference of 2 events and 1 total solar eclipse and 1 lunar eclipse, and they are happening one after the another, and these things you can calculate back. Okay, so you can go where actually it happened, at what time it happened. Planetary positions at the time of major events were mentioned there, Jupiter and Saturn in conjunction. Now, Jupiter and Saturn conjunction we have just seen in the November month last year. Okay, in November last year we have seen the conjunction very nicely. Okay, and it happens every 40 years. After 40 years, this happens. That we know. Then, if it is near Vishakha Nakshatra, Mibra, when the Great War started was written. So the Great War started when it was in conjunction position. Both those planets are there. So you can go 40 years, 40 years, 40 years, 40 years back, and then calculate with this eclipses, and then you can get only one time period. Okay, the culmination of all planets with the sun and moon 36 years after the Great War was also written. And there are mentions of many comets there in Mahabharata. So they are looking at the skies and mentioning the comets also. So the earliest mention of the comets we found in Mahabharata. Hence, the probable dating of Mahabharata is 1000 to 1450 BC. This is the period of Mahabharata, which is in new calculation. This is not regarding the calculation of Lokmanya Tilak or something. But today, if we go and see the almanac and go back, then this comes which is nothing, this is nothing to do with astrological prediction. Astrological prediction is something based on this, but not related with this. Okay, so if you say this is the first part, okay, this is the first, this area is called the first area or Rashi, then it is second, third, fourth, fifth, like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 parts are given. So on this part it is called Mesh Rashi. So what is fire? Fire means the fifth planet is in this Rashi. Okay, so like that it is. So if the planet, fifth planet is here, and sixth planet is here, seventh planet is here, okay, but here it is Ketu, then see Rahu is at third, so they are 180 and Venus. See, so if you see this arrangement, then you know at what time that event has happened. So this is a prediction of events done when there was no clocks available, because the invention of clock is just a recent thing, not at that time. Okay, we'll go forward. Then comes the Siddhantic astronomy around the beginning of Christian era, means 1000 years back. A new type of Indian astronomical research emerged that is called Siddhanta, which means well-established theories. So they say that it is well-established theories. So they are knowing something which is happened years together back, years together ago of their period, but they have written it. So many astronomy specific textbooks were written. Let us see some. So Aryabhatta 1, there are Aryabhatta 1, 2 and 3. So please don't misunderstood that Aryabhatta 2 has written something, Aryabhatta 3 has written something. No, all astronomical things are written by Aryabhatta 1, and their books are Aryabhatiya and they are also always they are in definitely in Sanskrit. So see, Bhugolaha, Bhugolaha means Bhu means actually sand, okay, ground. Golaha means full circle, but circle or sphere, Bhugolaha Sarvato Vrittaha means the earth is totally a sphere that is mentioned. Earth rotates, inferred from motion of stars. He has given that motion of stars are due to our motion, Earth's motion. Definitions for solar year and lunar month and sidereal day, etc. is given clearly. Then heliocentric distances of planets are given. See, up to that time, Earth was the center and distance from Earth was calculated. Only in Aryabhatiya, the distance from Sun is given for the planets. Then accurate value for the diameter of the Earth is given. Daily position of the planets is given. Then invention of the number 0 and decimal system. The pi was calculated something like this. The pi is 104 into 8 plus 62,000 divided by 20,000, which equals to 3.1416 was given in Aryabhatiya. Then sine tables is given, okay, and unique method of representing large numbers. If I want to write a number like this, then this number can be written very short, in short, and that was developed by Aryabhatta itself. What was that? It is like that. If you say a, then it is 10 raised to 0. If you say a, it is 10 raised to 1. So it is, if you say ka, then ka is 1, but ka is ka and a. Ka will be 10. But if you say ga, then it will be 30. See the difference. If you say di, then 8 into 10 raised to 3, then it becomes how much? So it is not, this becomes 80, 800 and 8,000. So this is the system. If you just write one single word, then it becomes something else. So if you want to have say about Ru, okay, if I write Rushi, then it will be a totally a value of Rushi will be too big to calculate. Why? Because Ru is 10 raised to 6 and she means what? 80 into 10 raised to 3. So this one plus these two. 80 into this, but Ru plus this. So that is the style of writing which he has adopted and which is a shortest thing possible for writing bigger denominations of all the mathematical denominations of figures. Okay, so this is, you can say k, k, g, g. So this is just Devanagari, no problem. So you now you can just calculate. This is fantastic. You just can calculate your own name in this fashion. What happens to it? Let us see. Okay, next. So Varaha Mihir was next. It is 499 to 587 AD. The books was Panchasiddhantika and Brihad Samhita. Here he has calculated the distances of moon, sun, and their shadows also. Okay, and this is one page of that Panchasiddhantika. So let us see what he has compiled. His compilation of existing astronomy at that time of Varahamihira, it also contains corrections of old texts and additions of Varahamihira. Measurement of diameter of the sun and the moon was taken, okay, with the help of just looking at it and calculating the angles. Prediction of eclipses was possible because of this. The moon and planets are lustrous not because of their own light, but due to sunlight falling on them was clearly mentioned. And observations of some comets were there in the Panchasiddhantika. But Panchasiddhantika means 5 different theories. Siddhanta means theories. So 5 different theories. Not all are important so much, but I will tell you Surya Siddhanta, which is compilation of material, author unknown. Original draft probably older than Aryabhatta, but and 40 miles, and this, if you relate it to modern, it is 7,926.7. So this is a difference is very less at that time. So you see the calculations are done today with so many beautiful measurement devices. It is not available at time, but still it has mentioned the distance between earth and moon is also given as 2,53,000 miles, and modern is 2,52,710 miles. Okay, just a difference of some miles, some thousand miles. So it is not much. And another thing is the best known Surya Siddhanta is Sarvadisham Suryaha Suryaha Suryaha, means all the heavenly bodies what we see is just like sun, all are stars. That is first mentioned in Surya Siddhanta by Varahamihira. That's why Varahamihira uh, only 2 have given, not 3. So, methods for calculating the positions of heavenly bodies over the time. So, ephemeridis was done by him. Rising and setting of heavenly bodies were calculated and given. Calculation of solar and lunar eclipses and conjunctions were predicted. Development of mathematics for astronomy was his own business. Second order interpolation, second order intermediate equations were there in Brahmagupta's writings, and he taught astronomy to Arabs. It was a reference from Al-Biruni, not from Brahmagupta, but from Al-Biruni's writings. He writes that Brahmagupta was knowing Arabians and Parsi, so he taught me. Okay, so then comes Bhaskaracharya second. Bhaskaracharya second is just 1140 to 1183 AD. Bhaskaracharya too, he comes from actually Maharashtra. Okay. The books is Siddhanta Shiromani, Karana Kutuhala, Lilavati, and Bijaganita. So Bijaganita, A, B, C, D, using denominations like X and Y coordinates. So everything was given by here. Okay, so we call it Chalana, that was given by him. In Lilavati, there are many problems given, and they are very. Actually, Lilavati was used as a textbook for many centuries in India. Okay, in what he has basically written with reference to astronomy is he calculated radius of Earth using a simple method which is given there. He stated that Rahu and Ketu are imaginary points and eclipses are a phenomena of shadows. His Siddhanta Shiromani consisted of two parts, which are one Graha Ganita. So this is mathematics of planets, and Goladhyaya, which is related to spherical geometry, not the geometry which we learn, which is a plane geometry. Okay, whatever we do is not a spherical geometry. Spherical geometry is totally different than what Euclid's geometry. So the length of the sidereal year, the time that is required for the Earth to orbit the Sun is given as 365.2588 days. The modern accepted measurement is 365 C25. Here 88 is there and here only 63 is there. So there is some decimal point, some some difference is there. Okay, no problem. So difference is just 3.5 minutes. Okay. Then a proof of the Pythagorean theorem by calculating the same area in two different ways is given there. In Lilavati, solutions for quadratic, cubic, indeterminate equations were given. This is more important. Okay. Then other important astronomers at that time was Parameshwara, 1400 AD. He commented on Surya Siddhanta, author of Digganitam, and also stated the model of heliocentric theory. See, the heliocentric theory, which we call in astronomy, is given by a person called Copernicus. He is not this much old. Okay, so heliocentric theory started here. Then Nilakantha Somayaji commented on Aryabhatiya and constructed a heliocentric model many years before Copernicus. This model is a beautiful situation that he tells that Earth, okay, because there was a pressure of many religious persons at that time, he said that okay, doesn't matter, Earth is at the center. Then around the Earth only Moon is going around, then Sun is going around, but all other planets are going around the Sun. So what is the in between thing? Only Earth is given away, and all other planets are moving along the Sun, like that he has stated. So, and Ganesha Daivanya is Graha Laghavam. So astronomical phenomena without using trigonometry, he has given how to calculate. So this is a beautiful book. Ah, from Graha Laghavam, we always take many problems to teach astronomy Olympiad students. Also in Tantra Sangraha, which is called Nilakantha Somaya Virachit, this is the first page of that. Okay, so I have just given this as a today there is not such time to go rave he pratik paramam prahu savanakyam nidamra. So every day how it moves, everything is given here. So I can just explain it to you, but not today. It will take time. So we'll go ahead. So there was a person called Lalla at that time, and he has given how actual instruments were used there. And the instruments were 12 instruments to see the sky. Golo, Bhagana Chakram, Ghanagati, Shanka Shakatakartayaha, Pitaka, Palashalaka, iti Dvadasha Yantrani, and Yastya means Yasti. So Yasti and all these things are totally 12 different units or instruments were used by him. His writing is Shishadi Vruddhi. It is 7000 AD at that time. Lalla was giving this. So these are the things. So these are the 12 things. Sphere, This is bow and arrow, he says, Dhanusha, okay, but this is actually a Konamapaka. He said Konamapaka, protractor. So this is just a protractor, but this is a line, okay, okay. Then disc, ring, time measurement with Gangala, and this is called Ghatika Patra. So horizontal disc to see shadows, cone, then for measurement compass, scissor shape instrument, then seat and needle, and then stick. So these 12 instruments were used for taking observations, which is written at that time. How they were used is something different. Now there is a totally new branch is open, which is called archaeoastronomy. So you see this rock art this is at Kashmir, okay, found at Kashmir. This is dated as 5500 BC, which depicts a supernova. So this is a supernova, okay, and these are not actually personal figures. This figure is not a deer or something. This is deer in the sky. This is also a constellation in the sky. This is also something in the sky. So that depiction at that time, so this is called a supernova, and we can go back and see what it is. So the supernova HG9 around 5500 BC was actually given here. And this is the place, just now you can see a nebula there. Okay, so this is Auriga, totally. Or we can in Indian language we can call it Sarathi. Okay, this is Capella. This bright star is Capella. Okay, so and this is, what is this? This is Orion or Mruga Nakshatra. And you know this. This is, do you know this? What is this? This is the hunter and this is the hunted. So this is the bull. Okay, so and this is the horse. This is the horse. We call it Ashwini. Okay, so Ashwini is here. So and sun is here. So if sun is here and another sun is here, then it must be a supernova. Okay, and which is that? So at that time, at this BC, and such things are now coming out, that these cave art is not referring to terrestrial things, but something with the astronomy. Okay, then astronomy was used in India for navigations. The Chola rulers, this area is called, just now it is near Chennai. Okay, so in 12th century, Rajendra Chola's naval expeditions were the Sri Vijaya Empire of Sumatra, Malaya and Java. So Sri Vijaya Empire, the king is residing here, but his kingdom is like here, all here. Okay, and how they were using this route. So this it is astronomical wisdom. And what is that? This is the astronomical wisdom they were using. So this is actually a depiction of Mruga Nakshatra, or we call it Orayana. So Orion, but they have Mruga Shirsham. This is called a Rohini, means Aldebaran. So this star is Aldebaran, Rohini. And these are Krutikas. Okay, the Krutikas, they call it, they are all mothers of Shanmuga. So the sixth face deity is called Shanmukha, right? So all 6 mothers are there, and this area is called Milky Way, and this is Pushyam. Pushyam means Procyon. Okay, so this is a kind of Canis minor. Okay, but Canis major will be somewhere here. So here, see how they have, so Bellatrix is Ardra or Tiruvadirai, which Betelgeuse, rise in succession at an interval of around 40 minutes. That was the calculation. Then about 40 minutes later, Agastya rises on the south horizon. They rise at dusk, soon after sunset in the mid-July, and rise later by an hour every 2 months, and rise early in the morning before the dawn, a few days before Makara Sankranti. So Makara Sankranti, see many, I'm not saying all, many of our holy days are according to the positions of the sun in the sky. Okay, so lying athwart the equator, they rise due to east and set due west. So they were well recognized as navigational stars. When Ardra rises in the east, Thiruvanam or Shravana, Eritrea, sets at the west and vice versa. So these stars are becoming the sailing guides for Chola period voyages. Now that is recorded. And now we come to some architectures. It's called Konark Sun Temple, where sun is in the center, but these doors, just like Stonehenges, if you see sun rising here, then center is equinox, and here it is solstice. One solstice here, second solstice here, and at the center it is equinox. Then this is not a wheel at all. This is a sundial in the Konark temple. So it is 12,050 AD. Then we go again back to western side. It is called Euroanometria, which was developed by Bayer. So he has taken all that Ptolemaic system again, and all the Ptolemaic 48 constellations, where this is the first map of the sky available today. So after the celestial spherical map of Arabian culture is available, then in at what time this is? This is just 1604. Okay, so 1604 this map was given, and Bayer also suggested Greek alphabets like alpha, beta, gamma, delta for the magnitude of stars. So one major thing for brighter star to fainter star, that gradation is done by Bayer first. Then again, there are 4 persons there in the history. They also have done these measurements differently, but he is the first person. Then this is Copernican system. That is the most developmental thing. So sun is at the center, Mercury, Venus, Earth with moon. Then there is Jupiter. But see the size. Okay, size of Jupiter is just like him. Okay, but there are 1, 2, 3, and 4 moons, because they are known moons at that time, because they can be seen with the help of telescope. So arrival of telescope is a historical thing now. Okay.
Excuse me, sir.
Yeah.
Sir, can we wrap up in 5 minutes?
Yes.
Yeah, sure.
I know that.
Okay.
So then comes Kepler. So Kepler has 3 different things. Okay. So he is a person who calculated how planets move around. This is the focus sun. So there is another focus, so elliptical moving. Then this area and this area is same. Okay, when a planet moves like that, and then if this another movement is given, so if this is 1 and if this is 2, then see, if this increases, the period increases by 3. Okay, so that is another thing. So Kepler, and after Kepler, we just go directly to our India Maharaja Savai Jai Singh of Jaipur at 1752. He has built a big observatory in 5 places in India. Just go and there and see how beautifully calibrated things are there. This is a actually sun dial, which is called Samarat Yantra. Okay, but see the intricacy, and all the big buildings are made there. Then you know Hans Lippershey is the inventor of the telescope, and Galileo Galilei is the user of the telescope. Then comes the bigger and bigger telescopes like this. This telescope belongs to William Herschel. We know what William Herschel is doing. So I'm not actually coming to modern history much, just mentioning some. What is the major things? Then the major thing is from Henrietta Leavitt. She actually calculated all the different luminosity and period relationship of stars, and then came to know that there are Cepheid stars. If that Cepheid star is like this, smaller, then it is bright. But the Cepheid star, they actually change their shape. They become bigger. If they becomes bigger, then the light curve is dipped and again increased. So one total period of variation, it comes a dip and again increase. So this much is there, but if the size of this star is increasing, then you see that this relation is, so luminosity and period relationship is very much there. So according to that, if we see some star and we calculate how much period it takes to become bigger and shorter, then where it is from us can be calculated. Its distance can be calculated, and just 100 years ago, when all the universe was thought that only our Milky Way is our universe, was totally banished by a person, and he calculated, this is that person, which is called Edward Hubble. Hubble. So what Hubble? Hubble calculated the distance using the Cepheid stars, and then he actually come that the near one galaxy is going away slower than a very far away galaxy is going away very fast. And another thing has come into help to him, that we can now take a spectrograph of slow spectrography come in, and then it helped to theorize a Big Bang. Okay, to theorize that how our universe was created and how it is expanding. So I think a total history is not shown to you. Some parts are shown to you, because every time if I want to talk about Henrietta Leavitt, then it will take 1 hour. If I want to show what is Hubble principle and what is Hubble constant, then it will take 1 hour. So I will conclude now that history of our India, what it has done. First of all, I can say the invention of zero and decimal system is more important all over the world. That is mathematical calculation developed with the help of astronomy. I think the astronomy is the first motivational thing in all. So you can take Newton also, you can take Einstein also. the thought behind going and discovering something which is hidden in the universe is the base, and that is called astronomy. Thank you very much.
Thank you so much, sir, for the wonderful talk. Definitely, we know that 45 minutes are not enough to cover the history, like European history as well as Indian history. But thank you so much for giving us so much new information about the history of astronomy.
Yeah.
It definitely took us with you through the long journey of astronomy, and it intrigued us till the end. So I'm sure many of us have some questions in their mind. So I request my friend Swastik to present the questions which are there on the Google Meet chart. Swastik, over to you.
I wanted to congratulate Anand for doing wonderful thing. This
Hello,
Professor
Subhankar.
Agarkar. This Professor
Yeah, yeah.
Agarkar. Huh?
Hi, Agarkar. How are you? Very nice
fine.
to see you.
Thank you for this. I have no question. I just wanted to congratulate him. We were colleagues.
Yeah, we were colleagues in Hoviwa Center long back.
Okay.
Yeah.
Go
Great to
ahead.
see you, sir.
Thank you, sir.
Go ahead. Sorry to interrupt. Go ahead.
Yeah.
That's
Otherwise,
okay.
तुम्ही पण आलात ते.
Swastik, over to you.
Yeah, thanks, Bhageshri. So there are quite a few questions in the Google Meet, so let's start with them.
Okay.
First one is, can we say that the concept of term astrology is similar to...
But
Swastik, we
I
lost you in between. So can you please repeat the question?
Yeah. So the question is, can we say that the concept of term astrology is similar to Jyotish Siddhanta?
Jyotisha? See, Jyotisha Shastra,
Siddhanta.
what we call Jyotisha Shastra is astronomy. Okay, Jyotisha Shastra means astronomy, but Phala Jyotisha means effects of the positions of the planets over the life of our life. Okay, the individuals, not all animals. Only one animal called man. Okay, if that is the thinking, it is called astrology. So the logy is different than astronomy, and it is a theory. They say it is a theory, they say it is a shastra, but who actually developed it, we don't know. Okay, and again, see, Varaha Mihira, he transferred it to us. Okay, if you go back, then at the time of Vedanga Jyotisha, there is no mention of zodiacal signs. Not a single zodiacal sign is mentioned in our astronomy, in history. Never. Only nakshatras are given, and nakshatras means 27 positions of moon. All our calendars also was on moon, not sun. Though sun is incorporated as a year of 12 moon cycles and plus something, and that plus something is Adhik Mas. Okay, that Adhik Mas is just to join them together with Vasanta Sampat. And that point also Vasanta Sampat was not considered that joining period, but Sankranti was the, okay, Sankranta. Makara Sankranta was the joining period, they say. So that was there. So all this astrology means the effect of planet position over the life of individuals was actually a idea of, I have shown you something like Chaldean or Mesopotamian area at Babylonia. So can you that Babylonia, in the Babylonia it started. Okay, and that story is well known, that there was a king and he's very badly ill, and so he hired somebody to predict what will happen. So that person said that if you do something like this, till I say, okay, and if the sun is totally vanished for some time, then take care of yourself. If you go through it, then you will survive. So that was given to him. That means after eclipse. If you remain after eclipse, then it will be all right. So at that time he started. So the history says that all this Phalajyotisha or astrology is not Indian. It came because of Varaha Mihira in his Pancha Siddhantika, one Siddhanta, out of one Siddhanta, when he mentioned Greek Siddhanta, okay, he written that this also is there, and it actually came from a person called Sikandar, you know, Alexander. When Alexander came to India, okay, to totally conquer India, with him this idea came to India, and then it is developed just because we can earn out of that. If you predict something that you will become good, if something good will happen to you, so this is a psychological game, and anybody can psychologically treat you, no problem, and he takes money. No astronomer takes money for nothing, right?
Yes, sir.
There is a saying that if you are in a eclipse position, if you are seeing the eclipse, you should not eat, and after the eclipse you have to take a bath. Now we were at Kanyakumari, okay, 15 January 10, 2010, which was a annular eclipse. On that time, on TV, I was there live, and I was eating with vada
Okay.
and showing eclipse to people. So I said nothing happens, because these predictions are all bogus. You cannot predict anything. You cannot. Nobody has predicted Corona. Have anybody?
No, sir.
Forget about it.
Yeah, so we'll move to the next question. So Joseph Prabhakar asks where to find details of the calculations.
Yeah, there are the nearby. Actually, in Bangalore, there is a big library. All the details of all these pages are available. In Asiatic Society, they are there. In TIFR, in our institute, Tata Institute of Fundamental Research, the library has all these books. Okay, and also English translations are available. I have taken this actually from a person called Mr. Dr. Mayank Wahiya. We call it Professor Mayank Wahiya. He's a he was there in TIFR also with us. I was working with him, and actually this history of astronomy, he has a bigger bigger slideshow which goes on for 5 hours. So from that, I have asked him to give it to me, and then I have presented to you. Also, I have seen something which he has there. He is a very good scientist, and he also does. I have shown you one supernova picture, which is called archaeoastronomy. So that thing is done by him. Okay, so he is just now in research of archaeoastronomy, and I am very much impressed. And there are some findings which are great. I have not incorporated all what he has. He has a very good collection. Also, he has done cultural aspect of astronomy. He has taken interviews of so many persons. Do they know? And he found out that the natives, we call it Adivasis, okay? So they know better astronomy than the city dwellers. and they have much knowledge, much more knowledge than us, who finds ourselves that, oh, what we know is only from books, but they actually see. When I was there at Nagpur area, Ramtek area. So I was with him at Ramtek area. So there a farmer, he showed me more stars than what I know. Okay, and the names which they have given them. So he says the names are not important, the positions are important in the sky. So if you remember the positions, then you can name, okay, any star you can name your name, no problem. You can, okay, Anand, na? So from today onwards, we say this star is Anand, no problem. Okay, like that. Because nobody has given, so that is called astronomer. So I called him astronomer. Actually, is not normer, it's astronomer. So the astronomer means the one who gives names to astronomical things. Okay, so become astronomy namer, no problem. But please look at the sky by yourself and go ahead and uh, whatever you see, just relate it. Just relate it. and
Yeah,
and,
so
and, and I can just, because there are so many students are there here, I can just say a few things that India is having 21 establishments of research area in astronomy. Do you know? And everybody wants researchers there. We have establishments, and every now and days, like GMRT, say Giant Meter Wave Radio Telescope is there. Okay, so there you can make research by, okay, take your own time, talk with them. They will allot you some time to do research and do observations, and on based upon that observations, you can have something in your hand. Okay, all foreigners come, they come here and they take all the charge of that telescope here, which is provided by us, TIFR people. Okay, and who is using that? Some PhD persons from foreign. And what our students are doing? Nothing, because they don't know that it is available. Okay, so just go to their website. Just go to the website of Devasthali. Do you know there is a telescope called Devasthali? Go to the telescope Hanley. So our Hanley telescope is at Ladakh, but which you can operate from Bangalore. Just sitting in Bangalore, you can operate that telescope at Ladakh and take the results on your computer directly. So you can do research on that. Not just taking advantage of what we already know, just go ahead with availabilities to develop your careers. I think we will stop here just now. Thank you very much for giving me chance to uh, say some things which I know with you, share with you. Thank you very much.
So, uh, yeah, sorry to interrupt you, but there are some questions, few more questions, I think. So.
Okay.
yeah, So N. Pramod Kumar asked, I would like to ask you that apart from research, how can we use this vast knowledge of astronomy to pluck out the roots of long-running superstitions, harmful customs, and all in staunch religious society through Athaang? Please give us your ideas.
If you just show, there is a very good saying of a person like Albert Einstein. He said that give a telescope to a village and all the superstitions will go. So if you just show them what it is, when you say something like what it is really there in the sky, which you don't see at all, if you see that with a telescope, then you come to know the actual universe, how it is, and how small we are. So when there are superstitions, they will just go vanish in one single night. I have seen people who came to see Shani, okay, because they have some problem with Shani in their horoscope. Okay, when they came here when they have seen actual Shani with the telescope, and when they know that it has a density of 0.66, that it is lighter than water because it is just a gas, and which is so far away that it is we actually find difficulty to find it in the sky. If I just say, okay, show me where Saturn is, then you cannot show me just showing that, okay, here it is, here it is, here it is, like that. Can you? If you know that much also, it is great. So that person, he was a Jyotishi itself. He was doing that horoscope business. When he came there, I said, okay, show me the Mangal today in the night. Show me where it is. So he said that, okay, he is in this constellation. Show me the constellations. How many bright stars are there in that constellations? He doesn't know anything. So when he really looks at it and see what the sky is actually, and what movement of the sun is happening, how the movement of the moon is happening. Okay, if you just see in the evening, yesterday evening, I was just taking a walk. Okay, when I was taking a walk, one person was with me and we were just chatting. So he said, oh, how beautiful moon is looking at. Tomorrow we can see a very good lunar eclipse. I said, no. So he said, why not? So I said, just now you see the situation of moon, where it is. Okay. If you know that it moves one full nakshatra ahead, ahead means on which direction? Down or up? So he was confused. I said, when at 8 o'clock today, you see towards moon and you should find out, is it in east or west? So if you are not clear of that, then how you can predict something out of it? You cannot predict this second day's moon, where it is and how it will be looking. So that much you should know. And then if you know that, then all the superstitions are gone. Because I know it is there. It will be there. Where to see a particular star in the sky and how? That you should know. Which IP should be used, which telescope is necessary, that you should know. If I want to see Pleiades and if I want to definitely see a Pleion out of it, which IP should be there? If you don't know that, then Shani will be with you, then Mangal will trouble you. Otherwise, somebody says that, okay, in your patrika, what you call it, horoscope, in your horoscope, at a particular position there is Mangal there, okay, and at particular position Shani is there. Array, that was at the time of my birth, not now. How can you predict something which happened? And if they were that at that time, they were beautiful. Otherwise, I would not have born at all. How you can say it is bad? It doesn't relate. Okay. So badness doesn't relate with you at all. And if you are not able to point out Shani in the sky, which is available just now, how can Shani will find you to do something bad to you? Very sorry. and also it is not actually doing anything. Why we see that Saturn? Because sun's rays go to it and then it gets reflected and we see a reflected point, right? A point like object we see reflected. He doesn't throw any light on you. So all these humbug things are beautifully avoided if you show them what is Shani. If you show them Saturn once in 4 years, that at some time you can see the rings of the Saturn from down upwards, and then you can see the rings after 4 years from upwards down. So you are looking at them from up and you are looking at from down, and at some time there is no single ring is available to see. Have you seen such things in Saturn? No, that is the beauty of Saturn. Okay, at some time you take Shani as without any rings, and another time only rings, and you cannot see the in between dot carefully. Why? Because your position, its position, that changes. So observation is the most important thing in our business, in our astronomy. So just try to take a photograph of any celestial object, then you will know that how much fast we are moving on Earth. You cannot pinpoint it. You cannot take a photograph which is shaky. Yeah, if you want to take a photograph of moon, it is very difficult to take a photograph of moon with just your hands and a camera. Then it shakes or blurs or overexposed. A white thing, what you see with your eyes, the camera cannot see. So, what is the problem? So, that problem, if you solve these problems, then all other things can be negated. No problem. You can negate them easily.
Yeah,
So there is one
we'll
last
take
question.
one last.
Yeah.
Okay.
Yeah, so we'll take one last question from here. So, how
Oh, I
the
cannot hear
records
you.
with supernova HG9? Yeah. So,
I cannot
how
hear you.
the records?
Okay, let me read it for
Ah,
you.
okay.
Oh yeah. How the records like supernova HG9, etc., was kept on a stone in 5500 BC, which could survive in today's era.
Yeah. So if you see a nebula, according to the size of the nebula, according to the radiation coming out of it, and what has happened years back can be calculated. Okay. So a supernova which has been seen by many persons around the world is recorded somewhere. Okay. So there are many records of supernovas, and there are many. Now we can take not only photographs of the nebulas and the stars inside that. So the star inside the supernova, after the supernova explosion is there, definitely it contains a neutron star, and the neutron star takes a rotation similar to its age. Okay, so how much fast it is rotating and how much slow it is rotating, that gives his age. So we can calculate out of that. So that record can be taken and you can calculate them. In astronomy Olympiad examinations, such records are given to students to as a problem solving sessions. Okay. Actual records of different observatories are given to students and given some questions and shown them how it can be calculated. So it can be calculated just by taking different, because we have lots of things now available. We have spectrograms available. Okay, Spectral photography is available now. So if you want a radio picture, if you want to have X-ray picture, if you want to have IR picture, if you want to see it in HR2, or how much hydrogen it is there and how much it is emitting, how much helium is there and it is emitting, because there is a ratio of hydrogen to helium in every explosion of supernova, and that can be detected. So according to that, its age can be defined. So if you know one thing, then you can just theorize another thing. First hypothesis, then taking actual notes about recordings, and then coming to the conclusion. That is the thing which is done. Okay.
Thank you so much, sir. Yeah. We know that there are some questions which haven't been taken, but surely you can always mail to sir if he is okay. You can always mail to him or to Athaang for your queries and questions.
I can one thing I can tell you that I have been writing the things, and also I'm answering questions of many students, and so on your blog, not a on your Athaang, you can make a one column like questions and answers. Right?
Yes, sir. Sure.
Post your
Sure.
question.
That's a good idea.
So you can post anybody's question there, and then let us write on them.
Yep, sir.
It will be more like open discussion forum, right?
Yes, Sundam, can be taken. We'll definitely think upon this. Thank you so much, sir, for the suggestion.
Okay.
And it was really a wonderful session. And thank you so much, all of you, for the interesting questions.
Yeah.
I'm sure you will definitely have more questions. Do write to sir or do write to us. We'll think. And
Any question can be, any questions can be answered. Okay. But they should be with science.
yes, definitely. And it shouldn't deal with superstitions. Yeah.
Okay, no problem. Because no question is bad or wrong. Answers may be wrong. But how can a question can be wrong? No question is wrong.
That's true. So let me request my friend Swastik to present vote of thanks. Yeah, Swastik, over to you.
Yeah, thanks, Pankajji. So it was a great pleasure interacting with everyone from different parts of India. I thank our today's guest speaker, Mr. Anand Gaisa, sir, for taking us on the journey through history of astronomy with him and explaining to us how astronomy evolved over time. Time was the only bound, or else we would have listened to you for eternity. I would also, on the behalf of Athaang's core team, I thank all the participants from GMeet and YouTube for attending the inauguration. Finally, I thank the members of the club for making today's event a grand success. Prachi, over to you.
Yes, first of all, before thanking and ending the session, I would like to request everyone to turn on their cameras so that we can take the screenshot of our first inauguration, that is the official inauguration. Last but not the least, I thank all the core team, including Akash, myself, Sangram, Bhagrishri, Swastik, Srishti, and Saeed, for working so hard in the establishment of the club. We promise you that you won't regret joining the club. Rather, we will try to reach out to more people and keep expanding the scientific community for building a better society. Hence, we will be back with more sessions and interesting programs for you. Until then, stay home, stay tuned, and stay safe. Bye.